Hello, my name is Alex. Now we're going over question number 7. For the matrix, find if it has an inverse, and then compute its inverse if it does have one. So I got the matrix of columns 2, 3, 4, 1, 2, 3, and 3, 4, 3. And then the book it says that to find the inverse, you basically just you're solving for 3 vectors or linear equations, and yeah, in this case it's gonna be 3, and you just solve for the 3 basis vectors, and in this case it's going to be the 3 basis vectors of R3. And so starting off, I just scaled the first row by 1/2, and then after that I multiplied -3 to row 1, added it to row 2, and that's going to be the new row 2. -4, I multiplied -4 to row 1, and then added it to row 3 to be the new row 3. And then after that I just scaled the second row by 2 to get that pivot 1 position. And then after that, I multiplied row 2 by -1/2 and added it to row 1. And then I subtracted row 2 from row 3, and that's going to be the new row 3. And then after that, I just scaled row 3 by -1/2 to take away that 2. And then lastly, I multiplied -2 to R3 and added it to the first row. And then I just added the second and the third row to replace the second row. And that left me with this. The inverse is going to be 3 with it's going to have columns 3, -7 halves, and -1/2. The second vector is going to be -3, 3, 1, and then lastly the last column is going to be 1, -2, -1/2, and -1/2, and that's going to be the answer on the right side.